right, we're going to start with law of cosines applications. A thought of the day: our road will be smooth and untroubled, no matter what care life may send, if we travel the pathway together with a friend. So, hope that made you smile. So, for law of cosines, we're going to be working sometimes in parallelograms. So I have to review parallelograms that you learned in geometry. Just a quick picture and some of the properties of a parallelogram that you learned before. Okay, so in a parallelogram, opposite sides are parallel and opposite sides are congruent. So this side and this side would be congruent. These two sides would be congruent. In a parallelogram, the diagonals are not congruent. So if you look at the diagonal from this corner to this corner, that would be your shorter diagonal, and the diagonal from this corner to this corner would be your longer diagonal. Also in a parallelogram, angles that are on the same side of the parallelogram are supplementary, or they add up to be 180 degrees. So say this is a 60-degree angle. The angle over here would be 120 degrees. In a parallelogram, because of parallel lines cut by a transversal, these would be alternate interior angles. So if the angle over here is 60 degrees, the angle up here is 60 degrees, and the angle over here is 120 degrees. So that's just a quick review before we get into example number 1. In example number 1, we're going to be using the law of cosines. Let me just review that real quickly too. Law of cosines is c squared is equal to a squared plus b squared. That's your Pythagorean theorem. That only works in a right triangle. The rest of the law of cosines is minus 2ab cosine of angle C. And remember, the side over here and the angle over here have to be the same. So for the first example, find the longer diagonal of a parallelogram with sides of 10.4 inches, 12.8 inches, and an included angle of 48 degrees. So I'm going to draw another parallelogram. Definitely not drawn to scale. What's given is the sides are 10.4 inches. So I'm going to say that this side over here is 10.4 inches. The other side is 12.8 inches. And the included angle would be between the two given sides, is a 48-degree angle. And we have to find the longer diagonal of the parallelogram. Using your properties of a parallelogram, if this is a 48-degree angle, this angle over here is 180 degrees minus 48, so this would be a 132-degree angle. If you look at the two diagonals, there would one diagonal that would go from here to here, across from the 48-degree angle. The other diagonal would go from here to here, across from the 132-degree angle. The longer diagonal will be the one across from 132 because that's the bigger angle. So now when I draw in this diagonal that I'm going to try to find, I know that the bottom is 12.8. The side over here is 10.4 inches because opposite sides are congruent. I know that this is a 132-degree angle, and I'm going to find this side. So I'm going to name my parallelogram. I'll call this angle A, angle B, angle C. I'm just just going to focus in on that bottom triangle. So this 12.8 inches would be lowercase b. This 10.4 inches is lowercase a. And what I am looking for is lowercase c. So now I'm going to go to my log cosines. Because I'm trying to find side c, I'm going to start it with c squared is equal to, the other two sides are a squared plus b squared minus 2ab cosine of capital C. Go to my notes, fill this in, and finish the problem.